Namaskar friends, welcome to the session 4 of our course on manufacturing guidelines for product design. And if you remember what we have covered till now, in the very first session we have discussed about the introductory aspects. Why do we need to study this course? What are the benefits of going through the course and what are the contents to be covered in the course? We have already discussed and highlighted in our introductory video. Then in the session 2 we have covered about the basic aspects or the classification of the manufacturing processes. What are the broad areas in which the manufacturing processes can be classified. Then in the last session, that is session number 3, our focus was primarily on understanding the processes, what are the advantages and limitations, but our target is understanding the process from the product design point of view. We have to understand that we have already designed a product, now we have to select a process which can be used for manufacturing that product. We are not going into the intricacies of the process mechanisms, that how the process has to be done or what are the various control parameters that have to be taken into account while designing the process. For example, if you see in the last session we have seen casting process. So we are not bothered about how to reduce the casting defects or what are the casting defects, because there are other courses which deal with the intricacies of the manufacturing processes. Our target is as a product designer to have an idea that yes, there is a process which is called casting process. It can help us to make very large size products, it can even help us to produce small size products, but in sand casting the dimensional accuracy may not be good. In order to have a better dimensional accuracy, we can go for a die casting process. So that kind of understanding we are trying to develop, that as a product designer I must know that if the product is to be made by aluminium or maybe to that matter any other low melting point metal, what are the processes available with me which can help me to fabricate my product or to develop my product. So this course is focused on those specific guidelines. Now for example, the size, we know that this is going to be the size of the product, this much inches is the length or this much inches are the diameter for the product. It has to be made in aluminium. So if we will see certain case studies related to this when we go further into the details of the course. But today we are trying to understand that what are the advantages, limitations and what are the various types of processes that are used for making of products. So again I am emphasizing that once our product design is ready, we have to select a manufacturing process. And why a selection of the manufacturing process is important? Because we do not want to do the iterations again and again. We do not want to modify the design again and again based on the manufacturing limitations of the organization. It may so happen that we have designed a product or a product designer has come up with the design specifications, and when these are submitted to the manufacturing department for the final manufacturing, there are certain manufacturing limitations which again call for redesigning or rethinking about the product design. So that can be easily be avoided if product designers focus primarily on the guidelines that already exist, which are we are not conducting any research or trying to establish any new guidelines for the processes. Whatever are already existing, if we are able to take into account those guidelines during our product design process, our iteration or maybe the time will be saved, and that is the most important parameter these days. Once we have a concept, once we have an idea, we can make a conceptual design, we can make a detailed design, we can do a prototyping, and finally we want to launch the product in the market as quickly as possible. And if you refer to the product life cycle of any product, maximum advantage, maximum leverage of the technology can be taken during the initial stages of the product life cycle. So each company wants to launch the product as quickly as possible in the market, and that is only possible if we do most of the things concurrently and use the concepts of concurrent engineering. And similarly, we are able to squeeze down the overall product development cycle. We don't want to waste even a single day. So therefore, once we are designing the product, we must keep all these manufacturing guidelines in our thought process so that the product is developed as quickly as possible. And therefore, we must have a basic idea about the various types of manufacturing processes as a product designer. So yeah, in the last class you have seen that we have covered sand casting and die casting, and we have seen that die casting has certainly got certain advantages over the sand casting process, but there are few limitations also. The limitations primarily is the high cost of tooling and the machine setup required in die casting. So it is only justified if we have to produce a large quantity or a large batch size of the product. So if large number of products have to be produced, then only we can justify the high cost of tooling that is important in case of, or that is necessary in case of the die casting process. Similarly, sand casting has also got its own advantages and limitations. So that is one of the important process which is used in industry for producing the products. Now let us see few other processes. Forging is another process. So we have already seen a primary forming process which is casting, and in casting also we have seen a variant which is die casting. There are other types of casting procedures also, like we can have investment casting process, we can have a centrifugal casting process, and then for molding also there are different types of techniques that are used for making the mold. So casting is a very versatile process, but we have just seen that casting can be used for making the products wherever the melting point of the metal is less, and we can easily melt the metal and pour it into the mold and produce the shape that is required. Similarly, forging is another process which is most commonly used for metals, and forging is a manufacturing process involving the shaping of metal using localized compressive forces. So we might have seen the blacksmiths, they produce fan hooks or other products, day-to-day products. So these fan hooks are an important example of the forging process. The blows are delivered with a hammer, often with a power hammer. So forging also has got different types of modifications or variants. We may have a hand forging, we may have a machine forging, squeeze forging, press forging. So different types of forging processes can be used. Now what is basically done, as is explained with the first two sentences on this slide, we take a metallic piece, we heat it till it's red hot, and then with the help of a hammer we give the controlled blows on this hot piece of metal and try to give it the desired shape. Now this process is also important and gives number of products in industry and can be used for making different types of products. Now what can be the advantages and limitations of this process, we can see, and as you can see in the diagrams, or also two diagrams are there. This is, you can see the forging process being done, and this is the red hot raw material or the red hot metal which is being deformed into a desired shape. And here also you can see this is a hammer which is being used to deform the shape of the metal. So we are not going to go into the details of the forging process, but let us try to understand that what are the advantages of the forging process. The forging can produce a piece that is stronger than an equivalent cast or a machined part. So what important guideline we can keep in mind, that if we are using forging as a manufacturing process, the part that we will get will be stronger as compared to the part made by the casting as well as the machining. So this is a very general guideline. There can be certain exceptions to this guideline, but generally as a product designer we can use this as a rule of thumb, that if for a specific metal we are using a forging process, we can get a stronger part as compared to if we make the same part or product by casting or by machining process. So, one general guideline: during the forging process, the internal grain of the part changes, or the internal grain structure of the parts changes, it forms, and continuous forging for a few minutes strengthens the part characteristics. So, the internal microstructure of the metal also changes on the continuous forging operation, and sometimes, or in most of the times, it imparts strength to the part. So, we can say that one of the major advantage of forging is that we can get strong metallic parts after the forging operation. Now, what can be the limitations of forging? So, hot forging increases the difficulty of performing the other machining operations on the part. So, if we are doing the hot forging operation, later on if we need to do the machining on the forged part, it may press certain difficulties, or it may pose certain difficulties. So, that thing we must keep in mind when we are designing a product. We must not suggest that first we will forge this part to the desired shape and then we will machine it. So, machining may have certain difficulties after the forging, or on a forged part there will be certain difficulties for machining operation. So, producing forged parts involves a lot of expenditure for the machinery, dies, tools and personnel. So, you can see skill is required if you are doing manual forging. Suppose I have no skill in the forging operation and I start doing the forging, I may not be able to produce a good quality forged part. So, therefore, skilled personnel are required. If we are doing a machine forging, we are using a die set for the forging operation, yes, skill is not required. The machine will be able to produce the part that we have designed, or the product that we have designed. But yes, one of the important limitations here again, as was in the case of the die casting in the previous session we have seen, is the high cost of the tooling, because we need to have a fully controlled system which will be able to do the machine forging and will be able to produce a good quality product using the forging operation. So, one of the limitations here again is the high cost of tooling, which must be justified with a large volume of production. So, large volume of production means large number of parts that can be made using that forging setup. If only 4 to 5 parts have to be made, these parts will not justify the cost that we will incur on procuring a forging machine or a forging setup. So, that is a common thing between a forging setup as well as a die casting setup. So, hot forging will lead to certain difficulties in the machining of the part, if at all it is required. So, it is advisable that once the part you are suggesting that it has to be made by the forging operation, we must take into account that we must not prescribe machining after the forging operation. This is a rule of thumb which is followed. Then coming on to compression molding. Now, we have already seen two important processes which are used for making the products with metals. Now, we are slightly moving our attention towards the products which are made by plastics. So, if we want to make a plastic part, we can use processes such as compression molding, we can use injection molding, we can use blow molding, we can use transfer molding. There are number of processes. Rotational molding is another process for making large axisymmetric hollow parts. So, depending upon the requirement, we can choose a process for plastics also. So, why we are trying to cover both metals and plastic? Because when we see the products around us, we see some products which are made out of metals, we see certain products which are made by plastics. So, our course is focused on a wide variety of products. So, we are not only focused on metals as the material or raw material or as a product material, or not only focused on plastics as the raw material for the product. So, basically our focus is on different types of products that can be developed and what are the manufacturing guidelines for different types of manufacturing processes. Now, let us see compression molding. What is compression molding? Now, compression molding process is one of the low cost molding methods as compared to injection molding and transfer molding. So, important point here is low cost molding as compared to injection and transfer molding. So suppose we want to produce a part where the cost of the part is very important. So therefore, in that case we may like to go for the compression molding process. It is a high pressure forming process in which the molten plastic material, what is the raw material here? The plastic material, we have to melt that material. It is squeezed directly into the mold cavity by the application of heat and pressure to conform to the shape of the mold. So we can try to understand it with the help of a diagram. In compression molding, if you see, two words are there, compression and molding. So we have to compress the raw material and it will take the shape of the mold and finally solidify as per the shape of the mold, and we will get our product. Now let us see, this is a simple diagram of a compression molding process. This is a lower fixed mold half, it is complying to a particular shape which I have highlighted, and this is the upper movable mold half. This is the shape of the upper movable mold half, and this is my charge, which usually we call as the raw material. So we have a raw material. This movable half will move down as it is shown here. It moves down, and this is the upper half, the lower half. When they will be in contact with each other, they will form a cavity here. This is a cavity, and this charge, which was earlier like this, takes the shape of the product. A very simple process which can be used for making of the plastic parts. So we are not going to go, as already highlighted in the previous slide, there are important control parameters here. That important control parameters can be, what is the temperature of the charge, what is the pressure that is being applied by the upper half of the mold, for what is the pressure, what is the time required for which you have to keep the two mold halves together. All these parameters have to be controlled in order to make a good quality part using the compression molding process. But what are the advantages where this process can be applied? That is what we need to understand. Now the advantages of the compression molding process are, the initial setup cost is not very high, fast setup time, so we can very quickly make the products. So when we have to produce large number of products, we can go for a compression molding process. The charge can be made ready, or the raw material can be made ready, put it into the mold half, close the two halves of the mold, keep the two halves closed for a particular period of time as decided by the product designer, and then you open it, your product is ready. Easy process, simple process, initial setup cost is not that high, and the cycle time is also very fast. Heavy plastic parts can be molded. Now suppose you have designed a plastic part which is large in size and is flat in nature. So the shape is also important, size of the product is also important, as we have seen in the previous sessions. When we have to select a manufacturing process, there is a criteria that we have to address, that we have to follow. So if the size is slightly larger, if the thickness of the wall is not that high, or the wall thickness of the product is not that high, and the shape is not very complex, then in that case we can go for the compression molding process. So heavy plastic parts can be molded. Good surface finish of the molded parts. Why? Because on both sides we have the upper mold half and the lower mold half. When you compress, the top surface also is very good, because the metallic finish is transferred on the plastic part. On the lower half of the mold also the metallic finish is transferred to the product. So top and bottom, both side, the surface finish is good. So the good surface finish of the molded parts, large size, heavy parts can be made by compression molding. Wastes relatively little material as compared to the other method. So whatever charge you can, what is the quantity, what is the volume of the material that is required for making the product, it can be pre-calculated, it can be pre-decided, and that decided amount of material is put between the upper half and the lower half of the mold, and then you compress it under the temperature and pressure, hold it for some time, it will take the shape. So the wastage of the material is very less in case of compression molding. So it wastes very less material. Thermoplastic composites with unidirectional tapes, woven fabrics, randomly oriented fiber mat or chopped strand can be manufactured. Now this point is relatively difficult to understand because it talks about a composite material. All these points are relatively simple to understand because they only talk about the plastic material. But many times this plastic material may be reinforced with certain fibers which may be available in the form of unidirectional tapes. They can be available in the form of woven fabrics, or even they can be available in the form of randomly oriented fiber mat, or maybe in the form of, the last form is also given, in the form of chopped strand mats. So we can make simple plastic parts also using compression molding, and we can even make composite products using compression molding process. In that case we will have two raw materials in the charge, or as a raw material going into the upper and the lower half of the mold. We will have polymer or the plastic also, we will have fiber in the form of cloth or in the form of chopped strand mat. So you put both these raw materials together in between the upper and the lower half of the mold, and it will compress this product or this raw material to convert it into a product. Now in this product we will have fibers also, we will have polymer also. So we can make composite material or fiber reinforced plastic parts also using the compression molding process. So that versatility, that flexibility also is available with the compression molding process. So we can make only plastic parts, we can make plastics reinforced with certain fibers also using the compression molding process. So we can see it is a very versatile process, can be used for large size part, surface finish is good, can even be used for making of composite products. Wastage is also very less. So we can say it is a very good process, but there has to be certain limitations. So what are the limitations? So limitations of the compression molding process are low production rate. So the production rate as compared to injection molding or blow molding is relatively less, limited to largely to flat or moderately curved part with no undercuts. So undercuts in the product design have to be avoided. So this is a good guideline for product designers, that if the product has to be, if the product is having a large number of undercuts, so in that case compression molding process is not advisable. Similarly, if the surface is very complex, three-dimensional in nature, compression molding may not be a good process. Why? Because here we have upper half and the lower half of the mold. From sides we may not be able to apply too much of pressure. So compression molding process is broadly used for flat surfaces or slightly curved surfaces only. It is not advisable for very complex three-dimensional products. So limited largely to flat or moderately curved parts only. So we can say with no undercut. So it gives us a limitation in our product design, that if our design has lot of maybe three-dimensional features, it is having lot of undercuts, we may not go for compression molding. But yes, as engineers we will never give up. There are processes, as you can see on your screen. We can use injection molding process. In injection molding you can see the presentation is already available on SlideShare. This diagram has been taken from SlideShare. Thermoplastic pellets are melted and injected under high pressure into the metallic mold. There are number of presentations, good presentations available on injection molding on internet. Even we have also developed a course on processing of polymers and polymer composites, where we have discussed all the details related to the injection molding process with the help of certain videos also. We have shown how the process actually takes place, but here we can see that in compression molding the material is compressed between the two halves of the mold and we get a final product. What are the advantages and limitations? Where the compression molding process is good, we have already highlighted. Similarly, in injection molding, what we do, this is the raw material here. This is the raw material, it comes here and then shear heating takes place during this barrel, and finally this is a sprue. It takes, this is my final product here. I am highlighting the product that we are trying to make using the injection molding process here. So, this is our final product that I have already highlighted. So, again here there is a, this is one half of the mold, this is another half of the mold, this is movable, this is fixed. So, the movable half will come and it will close down with the fixed half. In between we have a cavity, we melt the molten plastic, or we melt the pellets, and the pellets are pushed into the mold cavity between the two halves of the mold, and finally we allow it to solidify. Once it has solidified, we take out the product. So, this is slightly different from our compression molding process. So, what can be the advantages here? We can see that we can make a slightly more complicated design or slightly more complex designs using the injection molding process as compared to the compression molding process. So, here we can see the production rate is very high, close tolerances on small intricate parts. Another good guideline, intricate parts, if you have to make by plastic material, which is the process, injection molding is the process. Another guideline, size of the product will not be too large in case of injection molding, whereas in case of compression molding we have seen large bulky parts can be made. So, the size of the product has to be small, it can be slightly complicated, wastage is minimum here also, complex geometry can easily be produced. So, we have seen, we can see all around us. If I can give you the first assignment for the course, you can look around you and see and identify plastic products which might have been made by compression molding as well as might have been made by injection molding. You can make a table, compression molding, these are the parts around you in your day-to-day life. Similarly, for injection molding, these are the products which might have been made by the injection molding process. Now, what are the limitations? Again, the tooling cost is higher here because the mold design and fabrication is a tedious process. The mold cost is the most important cost in the whole injection molding setup. Setup cost is also high because we have to control, we have to see the melting of the plastic, and only that plastic, molten plastic, is pushed into the mold cavity. So, we have to control that also. We have to control n number of parameters for making a good quality plastic part using an injection molding process. So, the setup cost is high. So, we must only recommend injection molding process where large number of products have to be made. We must not recommend injection molding for a very small number of products. For a very small number of products, we can suggest rapid prototyping processes such as 3D printing. Only 4 or 5 parts have to be made. We can make them using the 3D printing process. But if the large number of parts have to be made, large number of products have to be made, then only we must suggest the use of the injection molding process. Here large undercuts cannot be formed. So, maybe smaller undercuts can be formed, but large undercuts it is even difficult to make in the injection molding process also. So, in our last 2 sessions, if you remember, or we can summarize that we have covered 2 processes which are used for making the metallic products, and we have taken 2 processes which are used for making the plastic products. So, with these guidelines, if we keep in mind these guidelines during our product design process, we can modify our design accordingly and suggest the process that yes, this process can be applicable for my product design. Although these are not the only processes, the list of processes is endless, but our objective is to orient the thinking of the learners in that direction that such type of information is available, and this information must be used while the product design process in order to minimize the time required for the launch of the product. With this we conclude the today's session. In next session we will try to wind up our first week of discussion by discussing the process capabilities, applications and exceptions of certain processes by taking appropriate case studies. Thank you.